All right. Okay, so the first side, or the front we'll call it, so A, B, C, D, E, and F, you were supposed to solve for moles. So it gets confusing. Capital M is molarity, not moles, equals moles over liters. So that's the equation you use for the entire worksheet, front and back, with the exception of 8, 9, and 10 on the other side. You got to use periodic table as well. But this is the molarity formula. This is what you're looking for A, B, C, D, E, and F. It was supposed to be repetitive. It was supposed to just be kind of like rote practice over and over and over again. So they give you a molarity, they give you a volume, you just cross multiply, essentially multiply them together to get the moles. So again, I'll show you how to do A, but B, C, D, E, and F are all the exact same. I'll read the answers, but I'm not going to go through each one because the setup's exactly the same. So when it says 500 milliliters of a 0.500 M Na2SO4, who knows how to read that? What's the proper way to read it? We wrote it in our notes Friday. So when you read that, you don't say 0.500 M. What do you say? Anyone remember? Think teeth. Molars, right, molar. 0.5 molar Na2SO4. That's how we read that. 0.5 molar solution of Na2SO4. So what is molar? Molarity. So 0.500 M is the molarity. We are looking for moles, and we divide it by the volume. Right, so if you look at the very top of the sheet, it says determine the number of moles. So we're looking for the moles every time. So the volume is 500 milliliters. Marcy, what's wrong with that number?
It's not liters.
It's not liters, right. So 500 milliliters, how do we convert that to liters, Dylan?
Divided by 100.
1,000. Right, take 500 divided by 1,000. Or just simply move the decimal 3 places to the left. So 500 milliliters becomes 0.500 liters. That's the correct setup for letter A. Now, again, I don't teach this way, but I said that backwards. I'm going to show you something. I don't really teach it this way, but I'm going to show you anyway. Some students like to rearrange their equation first. So if you wanted to do that, you could. So really, you would have molarity times liters equals moles. So if you wanted to realign your equation, instead of molarity equals moles over liters, you would just solve for this. So it would be these two numbers multiplied together equals moles. I sometimes think that's a little confusing, but you could do it that way, and you would have 0.5 here and 0.5 here. That's your molarity, that's your volume. Because really what you're doing is you're just cross multiplying. So sometimes it helps students if I explain it that way. You can set it up this way first. So how would you solve for moles without numbers? Set it up, then plug your numbers in. I don't know if that helps, but 0.500 times 0.500 is 0.25. Now, how many sig figs? So the answer is 0.25, but is it 0.250 or is it just 0.25? Who remembers the rule? When you're multiplying and dividing, what do you round your answer to for proper sig figs? The lowest number, right? How many sig figs here? 3. How many here? 3. They both have 3. So x equals 0.250 moles. Don't forget your unit. So you always need to show your work, always need to show your unit and proper number of sig figs. I know the worksheet didn't tell you to round to the proper number of sig figs. I didn't tell you to. So if you didn't, it's okay. But it's just good practice because the regents probably will ask you to do that. Okay? So I should probably update more of my worksheets, but we can just do it in class. So 3 sig figs, 1, 2, 3. All right, so that's A, 0.250 moles. B is 0.025 moles, 2 sig figs. I'm sorry, there should be 3 sig figs, so 0.0250. Technically it should be 0.0250 moles for B. Letter C, 3 sig figs again, 6.00 moles. It's just 2 times 3. Letter D, 3 sig figs again, 0.040 moles, 0.040 moles for D. Letter E, 3 sig figs again, 0.157 moles, 0.157 moles. Letter F, 0.145, 3 sig figs again, 0.145 moles. So again, it's the same setup every time for this front of this worksheet. You just have different molarity, different volume. Don't forget it has to be liters. Cross multiplied. That's how we got moles on the front. All right, flip it. All right, so here we go. I'm going to go through, I'll do 3 at a time. I'll set up 1, 2, and 3, and then show you how to get the answer. So number 1 would be x equals 0.50 divided by 0.30. Number 2 would be x equals 0.289 divided by 0.120. And then number 3 would be x equals 0.0877 divided by 0.075. So those are the 3 setups for number 1, 2, and 3. Check your answers. Check your work. You should always show work. If you have the wrong setup, then you probably have the wrong answer. So you're solving for molarity in 1, 2, and 3. So they give us the moles, they give us the volume. Sometimes it's in liters, sometimes it's not. Number 1, they gave us the liters, 0.3. Number 2, I had to convert it to liters by moving a 3 to the left. And then number 3, they gave us liters, 0.075. So again, moles divided by liters, that's using the molarity formula to solve for x, which is molarity. So now we just divide them. And this one, we get, let's see, 2 sig figs. So x equals 1.7 capital M. Capital M is the unit for molarity. Or you could do moles per liter. Either one, either unit's fine. Number 2, x equals 2.4 capital M. Again, 2 sig figs. Wait a second, should it be 2 or, nope, should be 3, sorry. 2.40, 2.40 capital M, 3 sig figs. Over here, 3 sig figs, nope, 2 sig figs. Skip that 0, 1, 2. So just 2 for number 3 and 1.2 capital M. So there's the answers to numbers 1, 2, and 3. Those are about as easy as it gets, honestly. 1, 2, and 3. They give you the moles, they give you the liters. You just plug them in and divide. It doesn't get much easier than that. You just have to know to use the molarity formula and know that the moles go on top, liters go on the bottom. I guess that's the only tricky part. You know, when we're doing it all at once, it's easier. You get to a regents and you have like one molarity question. You got to remember, okay, this is how I use the formula. So that's a little bit harder. All right, so that's 1, 2, and 3. 4, 5, 6. Okay, 4, 5, 6. This time we're looking for moles for 4, moles for 5, and then liters for 6. So for number 4, we're going to do 1.55 equals x over 0.600. I'll do one at a time here. So this time they give me the molarity of 1.55. They give me the volume of 600 milliliters. I convert it to liters by moving it 3 decimals to the left. So molarity equals moles over liters. They give me the molarity, they give me the liters. Cross multiply, so x equals, let's see, 3 sig figs, and that's 0.930 moles. So that's number 4, 0.930 moles. Number 5. So number 5, this time we're looking for moles again. The molarity is 0.954. X over 1.63, that's the volume. So again, in number 5, they give us the molarity. Capital M is molarity. They give us the volume, 1.63. Cross multiply. So for number 5, x equals 1.56 moles. 3 sig figs again. 3 sig figs again for number 5. Questions? No questions. Early with me?
Yeah.
Okay. Monique, making any kind of sense? Who else wasn't here? Marcy, you're good?
Yeah,
Mr. Dillon? Mamba? Okay. 6. This time we're looking for liters, so that's the bottom, right? So they give us molarity, 1.66 equals 2.11 moles, so 2.11 over x, right? So now they give us the molarity, they give us the moles, x goes on the bottom because that's liters. If you're a little shaky with this, I hope you're not, but if you are, you cross multiply, you get 2.11 equals 1.66x. You divide by 1.66, divide by 1.66. X equals, for number 6, 1.27 liters. 3 sig figs, 1.27 liters for number 6. I'm going to skip number 7 as far as going over it, but I'll tell you the answer. Answer to 7 is 2.2 liters, just 2 sig figs. 2.2 liters. It's just like number 6, except different numbers. 2.2 liters for number 7. Okay, I'm just going to save a little bit of time by skipping that. 2.2 liters for number 7. Questions? All right, keep this out. Open up your notes. Let's finish that problem from Friday, because that's only makes sense to me. Let's finish that first. I'll come back to the homework. I'll go over number 8 with you guys, and then 9 and 10 you can work on for tomorrow. We'll go over that again tomorrow. All right. So I'm pretty sure I made the question up Friday, kind of as I went here. So Morgan, can you tell me the question?
Calculate the number of grams in 238.
Number of grams in what?
Needed to create a 2.5 molar solution of chem.
Yep.
With a volume of 250 milliliters.
Okay, so we want to make a solution that has a volume of 250 and a molarity of 2.5. We have to find the number of grams. So the first thing we have to do, I think I talked about mole road last time. Let me review that real quick. So to get between these places here, you take mole road, and I don't know, I think this was particles over here. I think this was molarity down here, and I think this was grams over here, or something to that effect. And you can have fun with it. You can call these weird little places. I think I called this particle palace and gram land and molarity mansion, whatever. Whatever helps you have a little more fun with it. If you're here and you want to get to grams, right? So you're standing in molarity mansion, we'll call it, and you want to get to gram land, there's only one way to get there. You can't jump, can't fly. You either have to walk, run, take your cool car to gram land via mole road. So you got to take mole road. What's the analogy? What's the point? Well, what is this all about? What is the key to getting to all 3 locations? Yeah, you got to find moles first. You can't get anywhere without finding moles, right? So you got to take mole road. So you got to take the information the question gives you, which are these 2 numbers, use the molarity formula, get moles, then we're going to convert to grams. So first thing you're going to do is convert to mole road, stand in the middle of the road, and just wait there. Okay? Once you get the right answer, then you can continue on to find grams. So the analogy here is to find any one of these things, mass, molarity, number of particles, that's Avogadro stuff, mole box stuff, you always need to find moles. That's the moral of the story. And there's actually more little bubbles we can branch off of that, but the key is mole road's the way to go. So let's find moles first. So the molarity is 2.5. 2.5 equals X over 2.50 liters. So remember, we convert this to liters. That's where 0.250 comes from. Keep that 0 for sig figs. Cross multiply. I think we already did this, right? I think we got this far. What was it? Number of moles? 0.625. 0.625. Now, technically, you should only have 2 sig figs, right? 2 here, 3 there. But because it's an in-between step, what does that mean? We have another step to get our answer. You can really kind of keep as many as you want. At least 1 extra is kind of the AP rule. Keep 1 extra, so 2 is what it's supposed to have. We keep 1 more because there's another step. You don't need to know that for regents, but I'm just telling you that's how it works. So that's how many moles we have. Now we have to convert to grams. So now we go to the chart and we look up the mass of KNO3. So the mass of, I'll just do it over there. The mass of KNO3 would be 39 plus 14 plus 15, plus 16, 16, and 16, right? So we have 39, we have 14, and then that's actually 48. 3 oxygens has a mass of 48. So if you add 48 plus 14 plus 39, so we're taking the mass in the chart for each element, adding it up for KNO3. If we get that, or when we get that number, I believe it's 101. No? Yes, someone do that for me quick. 48 plus 14 plus 39. Yes, you did that? No. You were on? Yes. You sure? 101. Okay. So the mass, the gram form of the mass of KNO3 is 101. What does that mean? There's 101 grams in 1 mole. So remember, the mass on the chart tells you the mass in 1 mole. What are we going to do? What are we going to use that for? What are we going to do? Set up a proportion. So 101 is in 1 mole. We have 0.625, 0.625 moles. How many grams is that equivalent to? So again, we use molarity to solve this to find moles. Then we use the gram form of the mass of KNO3 from the chart. That's the mass of 1 mole. Set up a proportion. What's the mass of 0.625 moles? So 101 times 0.625, and we get something close to 63, right? What is it? 63.125. So x equals 63.1. 63.1, because that's 3 sig figs. 63.1 grams. So that's as hard as it gets on the regents for molarity problems. Go back to the homework now. Let's do number 8 together. And then again, number 9 and 10 we'll go through tomorrow. Okay, I want to have a little bit of time to intro parts per million. All right. So back to number 8. So number 8 says, what is the molarity in 650 milliliters of a solution containing 63 grams of NaCl? This question, we're working backwards from what I just did on the board, but it's the exact same concept. So I'm not going to put up my little analogy again, but this time we're in gram land. You got to take Mole Road to go to molarity, right? So we got to go from grams to moles, moles to molarity. So the first thing we're doing in number 8 is going to the chart. Who could tell me what's the gram form of the mass of NaCl? What's the gram form of the mass of NaCl? As soon as someone figures it out, please raise your hand or tell me what you got. Cassie? 58, very good. NaCl is 58 grams per mole. So that means there's 58 grams in 1 mole equals, right? We set up a proportion. This should ring a bell. We did this a few weeks ago at this point. So 58 grams are in 1 mole. Question number 8 tells me I have 63 grams. So 63 grams goes on top. X goes on the bottom. We're looking for moles. How do we solve for X? We cross multiply. 58 times X equals 63. Divide by 58. Divide by 58. X equals, someone do that for me, please. 63 divided by 58. Kira's got it. Give me 3 sig figs would be good.
1.08.
1.08 moles of NaCl. So now, if you go back to question 8, the way I want you to read it is, what is the molarity in 650 milliliters of a solution containing 1.08 moles? Because you have grams in the question, we just converted it to moles, that's all. So 63 grams is equivalent to 1.08 moles. Now, for number 8, we have to solve for molarity. So we take 1.08, we take the volume 650, and Emily, how do we set that up?
You put 1.08 over 650.
Close, not 650 though. Because 650 is in milliliters, we need liters.
So 0.6.
Very good. So 1.08 divided by 0.650. We divide 1.08 by 0.650. That gives us our X, which is molarity. So go ahead, Morgan, what'd you get for that?
1.66.
Yeah, we need 3 sig figs, 1.66 capital M. That is the answer to number 8. That is the answer to number 8. 1.66 moles per liter, or capital M, which is molarity. Same thing. Okay? Wait a second. I have 1.67. Oh, you know why? Because that's right. That's right. Good job. 1.66. All right, so number 9 and 10. If you already did it, good job. If you didn't, finish that up for tomorrow. Let's go back to our notes. We're going to intro parts per million. Yeah, we got enough time. All right. Okay. All right, so here we go. Parts per million. Parts per million. Okay. So I'm just going to jump right into the practice problems here. That's the best way to learn this. But I do want you to take out your reference tables and look at the back of them and look at the parts per million formula. It's a little different than molarity. There's no moles involved at all. So again, what is parts per million? It's basically how much solute is dissolved in 1,000,000 grams, sort of the solution. So what's the ratio between the solute solvent, but in terms of like 1,000,000 grams? That's kind of what parts per million means. And again, it's used for maybe contaminants in rivers, lakes, streams, you know, mercury, for example, or lead levels in drinking water. And that's where this would come into play. So anyways, if you look at the back of your reference table, parts per million equals grams of solute divided by grams of solution times 1 times 10 to the 6th, which is 1,000,000, right? So this is a little bit more challenging because you have that million that you have to kind of deal with. So I'm going to try and give you at least two sample problems. We'll get at least one, hopefully 2. So I'm just going to write it down, copy it, use the equation. I'll give you a couple minutes, see if you can figure it out. All right? So here's the question. Calculate the parts per million of a sample of, we'll say, river water. Calculate the parts per million of a sample of river water containing, let me see, I'm trying to make a number that makes some sort of sense here. Let me get a better visual here. Containing, I don't know, let's say 250 grams of lead dissolved in 2,000 grams of river water. Probably should have just wrote the word water, but of course I have H2O. This is kind of an easy one, kind of a straightforward. Calculate the parts per million of a sample of river water containing 250 grams of lead dissolved in 2,000 grams of river water. So you set it up as you're working. I'm going to keep talking here. So a typical Regents question will be some sort of lake, river, or stream, I don't know. They'll give you a scenario, and they'll say, okay, you have 2,000 grams sample of this river. It's found that there's 250 grams of lead. What is the parts per million? I didn't word it exactly, I didn't word it very well, but the gist of it is, can you take the information, plug it in the equation, solve for parts per million? So you do need a calculator. So if you need one, you can come up and grab it. And if you have a rinky-dink calculator with no powers of 10, you just have 6 zeros, right? So 1 and 6 zeros is 1 times 10 to the 6. Hopefully I made a number up that makes sense. Sometimes I make these up and the parts per million is like outrageous. Yep. If you have a lead concentration of this number, you'll just die instantly as soon as you drink it. So I didn't pick a very realistic number, but that's okay. I thought my grams of lead is way too high. That's okay. We're just practicing using the equation. We'll do another one after this. What do you guys think the unit is? What's the unit on this thing here? All numbers need units. Any guess, Cassie? Very good. Parts per million, that's your unit. Actually, you can abbreviate ppm. ppm, parts per million. So again, most you guys are all getting the right answer. Good job. Most parts per million questions are going to be somewhere between like 1 and 10 parts per million, not 12,000 or 120. Is it 12,000 or 125,000? I can see in two different answers. All right, well, let's see. So if we do parts per million equals 250 divided by 2,000. That's times a million. What did I get? I cleared it. Well, I'll just do it real quick. 2,000 is the bottom there. Times. I got 125,000. 125,000 parts per million. So I guess I didn't think that through well enough. That number is ridiculously high. I want to say a safe sample of like lead in your drinking water, a safe parts per million would be like 1 part per million, not 100. I mean, it would just be one solid piece of lead. I mean, that's ridiculous. So that was a stupid question. That was my bad. As far as this number, I probably should have picked like 0.25. That'd be a little better, but still. So if you can do a very simple one like this, that's good. Let me give you a hard one now. I'll try and squeeze it in before the bell. While you're working on the second one, I'll give you your worksheets. All right, so here we go. All right. A sample of, we'll use a lake this time, lake water with a mass of 5,000 grams has a mercury concentration of 1.5 parts per million. Calculate the mass. I'm going to change that. Calculate the number of grams. Calculate the number of grams of mercury dissolved. Make sure you copy that down. This is a harder question. This is about as hard as it gets as far as the regents. They give you the mass of the solution, right? The lake water is your solution. They give you the parts per million. Now it wants you to figure out, okay, if this is the mass of the solution and this is the concentration in parts per million, you tell me, or you calculate how much mercury is in there. So you're still using the parts per million formula, but you're solving for a different part. You're solving for the mass of the solute. That's different. So a little more algebra involved here. Both of these worksheets coming back to you here. Again, it's not a ton of work, it's just 2 worksheets. This first one coming back, I circled the problems that you're supposed to do. You might be one short, Max, let me know. Again, this worksheet here, I circled this problem. You're short, Bree? Sorry. All right, well, we'll go over all of this tomorrow. nothing like trial by fire. Figure it out as you go. Have a wonderful day.